Welcome to the Stormsurf video surf forecast for the week starting Sunday, February 26th. Looking at significant wave heights for the North Pacific Ocean, we see a rather calm pattern in play. A little bit of low pressure, presumably over Vancouver Island, generating small seas, not even in the 17 or 18 foot range. Another cutoff low, presumably north of Hawaii, generating 17 foot seas, aimed in the wrong direction at Japan, not at Hawaii, not at the U.S. West Coast. And other than that, a very calm pattern is in play. Let's get into the details. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a dip to the south in the jet stream, and we don't see any here, we don't see any here. There is just the tiniest little nub of a dip or a trough or whatever you want to call it, and that would support counterclockwise flow aloft and down at the surface. That's the hallmark of low pressure, and of course low pressure generates wind, winds generate seas, and seas generate swell, which of course makes surf when it hits your beach. But this trough is basically landlocked, not supportive of gale development, maybe precipitation. And in fact, some of that precipitation is working its way through Oregon down into northern California and is supposed to make a little bit of snow in the Tahoe region down the Sierra, but not a whole lot. What we do see here is a massive split in the jet. The northern branch moving up over the Aleutian Islands into the Bering Sea, into Alaska, and pretty much down the coast, not doing anything. The southern branch doing the opposite, heading south and then coming back northeast over Hawaii and into Baja. And what you typically get in between these two streams of the jet is high pressure, massive high pressure, likely setting up right in this region here. That's not good for storm production. We'll roll this out and see what's happening over the coming days. Monday, pretty much the same thing. You get a hint by Wednesday that maybe the split is going to back off, but then sure enough, a couple days later, we're into Thursday night. Another split tries to develop over Japan, and then yet another split here. Notice there is a bit of a trough here, kind of a very steep trough here on Friday, setting up on the date line. But again, relative to the bulk of the Pacific, just not a really good pattern. Look at that. It actually retrogrades. The split goes back into almost Russia and then comes back the whole way through the Bering Sea. Maybe a little low pressure here could develop. That's sort of a trough there on Saturday in the northern Gulf of Alaska. And then we continue on. We'll just roll this a week out. Now, the jet looks like it's trying to consolidate, and that maybe this, you notice this is like a cutoff upper level low sort of thing here a week out. That might blow off, but the suspicion is the inactive phase of the MJO is in control. Notice there isn't a whole lot of energy here in the jet. When there's not a lot of energy in the jet, it tends to split, and that's just the way it goes. This is pretty much the normal cycle, so nothing to be too surprised at. Let's go take a look down at the surface. So here we are, surface level pressure, surface level winds, and as expected, weak low pressure here over somewhere between Oregon and Washington. 1,008 millibars. That's hardly even low pressure. Yeah, it's low pressure relative to the impenetrable 1040 millibar high here in the Gulf of Alaska. And then we also have, as expected, cutoff low here north of Hawaii at, what's that, 1016 millibars, and almost another little cutoff low here, trying to organize somewhere between Hawaii and California. But we know that the bulk of the jet stream energy is up here. These lows are therefore cut off from the main jet stream flow and have little chance to develop into anything stronger. So we'll roll this out, see what happens, and as expected, both those systems just kind of dissipate. A little bit of low pressure tries to show up here in the northern Gulf on Tuesday, another low pressure over Kamchatka on Tuesday. Neither does anything. Here we get this interesting kind of, I assume this is the jet is coming here and then starting to push north, but probably a cutoff low just the same into Wednesday, Thursday. A little bit of fetch, maybe aimed at Hawaii. 40-knot winds there. Let's see where this goes. And sure enough, there you go. There's some decent fetch. 35 to 40-knot winds aimed at Hawaii by Thursday night. Pretty good size low. But again, cut off, if I recall correctly. Oh, no, there's that pinched off trough right here. That's where all the energy is getting imparted to this low. So we're still on Friday. We're into 40-knot winds out of the northwest. And then it starts fading out on Saturday. So maybe some hope for Hawaii. But other than that, then we get into another kind of a pattern, 180 hours out. But given the kind of convoluted jet stream flow, suspect not a whole lot is going to emerge out of this. Let's go take a look at the wave models. So here we are, a little bit of seas here. What's that? Probably 14 foot, 15 foot again. And then the other cutoff low north of Hawaii with, it says 19-foot seas. We'll give it 18 foot. Either way, nothing expected from that. We roll this out. Again, a little bit of a low pressure here as we saw in the Gulf on Tuesday. Was that 24, maybe 25-foot seas? But quickly moving out of the swell window for Central and North California. 20-foot seas. Nothing else really going on. Roll this out. Then we have this low. Remember that really tight kind of pinched off trough developing on the date line on Thursday. And by about Friday morning, we have, 24-foot seas aimed decently at Hawaii. Building in coverage, but not so much in height. 23-foot seas into Friday night. And then the whole thing fades out. Now notice there was larger seas north of there, but they're all aimed back at Kamchatka and the Kuril Islands. No swell expected for our forecast area from that. And then we roll this out. We're just sort of moving out to 180 hours and maybe some spurious areas, seas. 22 foot, maybe 17 feet there. Just really nothing impressive at all. Again, all driven by the jet stream, and the jet stream all driven by the MJO. And so, it's kind of expected that things would be quiet at this point in time. So let's go take a look longer term and see what's going on. Oh, wait, before we do that, let's take one quick look at precipitation forecast. Okay, so here we go. We start with the GFS and just high-level kind of forecast. We see, and we're looking mainly for precipitation in the Sierra. We see, as expected, our low pressure here over the Oregon-Washington border. A little bit of, snow, cold precipitation, cold core low falling south, and that's what happens when you get high pressure out here, low pressure inland. The winds and the systems tend to fall south, so it doesn't take a very much liquid to get a lot more snow because temperatures aloft and down lower are much colder. Anyway, so we see a little bit of precipitation working its way into Tahoe by Sunday night and into the southern Sierras by Monday morning, and then pretty much filtering out. Another sort of pulse to develop Monday night, but not really even make it anywhere near the Sierra. It just sort of falls apart. And then notice high pressure starts ridging inland. That's actually kind of a good thing. If we can get this high pressure out of the way, that'll open the door for low pressure to move in and start producing more precipitation, but that's not to be the immediate case. High pressure looking pretty strong even into Thursday, Friday. Little sense that maybe by Saturday, high pressure starts moving out of the way, but see over here, another high pressure starting to work its way in. We'll see. Snow for the mountains of Oregon for sure by Saturday night, trying to fall south. Boom, doesn't make it. Again, high pressure just locking things down. And so again, the split jet stream, the high and dry kind of pattern, certainly influenced by the inactive phase of the MJO. Though notice low pressure out here trying to push in. Don't know if it will dislodge the high quite yet because the jet is not driving strong enough in this region to basically push the blocking high out of the way. Let's go take a look real quick at the zoomed in high-res model. So here we are starting looking at 1 p.m. Sunday. And come Sunday night, 7 p.m., so just about an hour ago, supposedly snow starting to build in the Tahoe area. And by snow, we're not talking a lot. The model actually makes it look stronger than it is. But it goes through the evening, 4 a.m., 7 a.m. Monday, and things clear out. Total accumulations, we're looking at, 4 inches, 3.5, 4 inches, that sort of thing across most resorts. So basically dust on crust for most of the resorts, but that's okay. There's a huge base in place right now. As long as it doesn't get real warm or doesn't start raining on it, there's piles of snow there. If it can just hold long enough till the jet stream gets its act together and starts dumping some more, just unbelievable coverage and amounts of snow in the Tahoe region. We'll do a quick look here, playing the same game, Mammoth, right here, right underneath the controls here, and we'll just roll this out. Here comes the system. By 4 a.m. Monday, snow moving into Mammoth, light snow, and pretty much gone by 10 a.m. Total accumulations, 1.3 inches. And, well, a couple of showers there lingering afterwards. Okay, give it 1.5 inches. So, again, dust on crust. All right, so let's take a look long term. Let's see how things are going to play out. When will the inactive phase of the MJO lose its edge, and what's going on with El Nino, La Nina, collectively known as the ENSO? As always, we start our tour looking at winds in the Kelvin wave generation area. Box, draw it from 130 east. So basically north of, this is New Guinea. Here's the equator. This is the West Pacific. This is the East Pacific. So, okay, and the Kelvin wave generation area, 5 north to 5 south, from way in far in the East Pacific to 170 west, just the other side of the date line, and there. And what we see, of course, is strong easterly winds over the entire equatorial Pacific. Okay, that's not unexpected. Relative to normal, anomalies, differences from normal for this time of year. Actually, winds are a little bit weak here in the East Pacific, and this is kind of key. It's setting up westerly anomalies. That is stomping on upwelling in this region and helps produce warming at the ocean surface. Now, over the Kelvin wave generation area here, we see still light easterly anomalies. That's indicative of the inactive phase of the MJO. So what's the forecast for this region? Okay, Kelvin wave generation. This map, the whole planet on one page, going back in time, January 27th. But the Kelvin wave generation area is basically between these two tick marks. So you just draw a line down in your mind between these two tick marks going down. Reds and yellows are westerly anomalies. And those, of course, would help support consolidation of the jet stream, more wind in the jet stream, and help produce feed storm production, especially over the dateline region, Gulf of Alaska, and that would help produce swell and storms, of course. And the blues and purples are easterly anomalies. So in the Kelvin wave generation area, this has been the standard kind of pattern. Right around somewhere on the dateline, just west of the dateline, there's been easterly anomalies associated with La Nina. There's this tendency of westerly anomalies to try to build into the Kelvin wave generation area, but not really make it, like here on February 16th. And then this was really the start of our latest inactive phase of the MJO. Easterly anomalies taking over the Kelvin wave generation. Here you go. You can draw the area right here, going down here. Easterly anomalies in control and continuing expected control of the Kelvin wave generation area into March 5th. That is a week out. So again, this would support the thesis the inactive phase of the MJO is in control. Jet stream is to remain split. Not good support for storm formation and therefore swell production, and probably putting a damper on precipitation in the over the East Pacific, specifically in the Sierra. At least that's our thesis just by looking at the objective data. Now let's go look at some of the models and see what they say. Outgoing long-wave radiation model, statistic model. The reds and yellows, so outgoing long-wave radiation is how much sunlight or radiation is being reflected off the ocean surface. The more you see, reds, that means positive values. That tends to mean high pressure, that tends to mean easterly anomalies, and that tends to mean the inactive phase of the MJO clearly in control of the West Pacific, and forecast per the statistic model to continue to hold in the dateline region, Kelvin wave generation area, but starting to lose energy 2 weeks out and just covering over a small area on the dateline at that point in time. The GEFS model, dynamic model, suggests much the same thing, a little bit different. It just suggests it getting weaker, but we suspect the statistic model is actually doing a better job of this than the dynamic model at this point in time. Another way to look at the forecast, phase diagram charts. Assume the circle here is the north pole of our planet. You're looking down on it. The active phase of the MJO is right where this dot is, so basically in the Indian Ocean. The further away outside of here it is, the stronger it is. This is the past position. These are dates like February 9th, 10th, 11th. This showed the active phase of the MJO strong in the West Pacific, and we were getting lots of precipitation at that time, and the jet stream was well consolidated and raging. But then by about the 18th, 20th or so, the active phase moved somewhere between Africa and the Indian Ocean. Jet stream fell apart. So basically you could look at it and say, this is where the active phase is, so the inactive phase is in the exact polar opposite quadrant, or basically in the West Pacific. And so the active phase right now is, in fact, in the Indian Ocean, moderately strong, forecast to collapse to nothing over the next 2 weeks. This per the ECMF model. The EFS model, GFS ensemble model, saying basically the same thing. The 40-day model, upper level. Now this is precipitation, or the propensity for precipitation. Orange and yellows are dryness, and this runs about 2 weeks ahead of what's actually going on at the surface. So the peak dryness is somewhere, we'll say, south of Hawaii right now. Let's see. There's Australia, New Guinea there, South America, and Mexico. So basically, the inactive phase is to start moving into the Atlantic on the 13th of March per this, but actually it'll probably be a little bit behind that. But also notice that the active phase is to start moving into the West Pacific, roughly the 6th of March, 13th of March. But remember, this runs ahead, so it'll probably be more like the 20th of March or so, and then working its way across the Pacific through this per April 2nd, but probably even later than that. So this suggests the active phase of the MJO coming in, let's just say, later March into early April kind of thing, followed by, again, the inactive phase of the MJO by late March into early April. And then finally, our trusty CFS model, 850 millibar winds. This is winds at 4,000 feet roughly. Reasonably good approximation of what's going on down at the surface. Here is where we currently are, February 26th. Now this model, past history is back here. The future is here. Now you can clearly see easterly anomalies, the blues here. Forecast dateline region right here. Kelvin wave generation area roughly between here and here. So this also suggests inactive phase in control, but you can see it kind of moving off to the east. In fact, let's overlay the MJO. The dotted lines are the inactive phase. Dotted contours, inactive phase. So from now through about 20th of March, pretty much that's in line with what we're seeing on the other models. Inactive phase in control. Then the active phase shows up end of March, let's say third week of March, and kind of tries to come in, but doesn't. And then really comes on strong in early April. And again, now this model has been constantly showing these big patch of westerly winds building at some point in the future. And there's some stronger active MJO pattern setting up. And notice this really strong westerly anomalies as you get into later April. We don't believe any of it, but clearly this inactive phase is consistent across the models, and some sort of active phase will result behind that. Now, what's driving this strong, the model trying to believe that something strong is coming? Low pass filter here. This dotted contour shows the La Nina pattern in play, and it's shown, and this isn't El Nino, but it's basically the polar opposite of La Nina. And what's supposed to happen is La Nina is certainly dying. We'll get into that in a second. It's supposed to be completely dead, even in the upper atmosphere, by about the 16th of April. So we're not too far out from that. And then supposedly a El Nino-like pattern is to build, and that's what's driving the model saying strong westerly anomalies. We don't believe any of that. I think the best belief here, we'll just take this out of the picture again, is that we're sort of sentenced to a split jet stream, weak storm track, and probably dry weather till about the third week of March. But after that, then we could return back to the pattern that we've been in prior to that, basically all fall and winter. And that's a wetter pattern for the Sierra, and maybe some storm activity and swell production, but nothing. I mean, this whole year has not been super productive, not unexpected with La Nina in play. All right, so let's move from MJO to the El Nino La Nina thing. First, we'll look at it in the ocean. The ocean component of La Nina, West Pacific here, East Pacific here, looking down at depth. We see warm water in the West Pacific, a very shallow pool of warm water in the East Pacific. But the key point is, and we brought this out last week, the 26-degree isotherm, which was chopped off even west of 140 a couple weeks ago, has all of a sudden started making significant inroads to the east. Now remember, we saw westerly anomalies in this area, meaning trades were weaker than normal. That allows, so rather than having this nonstop easterly flow on the ocean surface, pushing warm water off to the west, creating upwelling in this region, what you now have is weaker east winds here. That allows some of the warm water to slosh back. Now, not really a Kelvin wave. It's probably more just sunlight heating the ocean surface, giving it an extra degree or two, which is enough. Anyway, and anomalies, differences from normal from this time of year. We see all our warm water, whatever it is off here in the West Pacific, not making it across the date line. Now, this is the interesting part here. There was a pretty good-sized pocket of 1 degree below normal anomalies here. That is all but vanished. It's basically just neutral anomalies. There's your warming there, a little bit warmer than normal at the ocean surface. But at depth, La Nina did have 3 and 4 degree below normal degree anomalies in this region. Now it's almost neutral, and basically La Nina appears to be dead. Another flavor of that chart, and this is a significant upgrade from even a couple of days ago. So here was all our warm water off in the west, and we'd been seeing hints of warm water moving to the east. We also had a cool pool right here, but it's gone now. We see this flow of warm water subsurface now. This is down 100 meters or so, but you're starting to see the spigot open and warm water starting to move back to the east. That's a sure sign that La Nina is dead. Now, one would love to say it's a Kelvin wave and that El Nino is trying to make a stand, but I think that's way too premature. It's just more warming developing in this area, returning the ocean to more of a normal balance or more homogeneous depiction of warm water across the Pacific at depth. Upper ocean heat anomalies, upper 300 meters of the ocean over time. Back in March, La Nina, cool water coming from the West Pacific to the east. There was the last little bit of our El Nino in March of 2016. So we're back a year ago. La Nina came into play. Cool water moved in. But now look, here we are. Come December 2016, El Nino started really fading out. Cool water started dissipating. Warm water started moving back in. Trades started losing a little bit of energy. And here we are right down here, just the bottom pixel line here. You see warm water making its way, and by warm we're talking not, just half a degree at max, one little pocket here of a half degree to 1 degree, but pretty much just a normal distribution of water across the equatorial Pacific, surely indicating the death of La Nina. But what we're seeing in the atmosphere still is the hangover from La Nina. It'll probably take 3 months or more. It was a weak La Nina. The weaker it is, the quicker it is to get wiped out of the atmosphere. But it only died, a month ago or so. So it'll probably be before it'll be the springtime till we really see a normal atmospheric flow in play. So next we take a look at surface temperature anomalies. Okay? And here's where things really get interesting. Lots of warm water building here along Peru and Chile and Ecuador. And last week, I think we saw a cold finger of water pushing off Panama, almost to the Galapagos Islands. That is all gone now. Now remember, easterly anomalies or easterly winds, trades in this area are much weaker than, well, not much weaker, but they're weaker than normal. Well, there's actually westerly anomalies here. That's helping to build warm water. It's preventing upwelling, and it almost gives you this appearance like El Nino's building. I mean, what's that? That's the deep shade of red there. We're down to 4 degrees above, or up to 4 degrees above normal here in northern Peru. Normally, what you see, that little pocket of cooler waters right there, normally that's the whole way up into here. But it is completely retreated, and this El Nino-like warm pattern has been building and taking control, and it's not just limited to the Nino 1.2 region, the Nino 3.4 region. The main area used for monitoring El Nino starts right here and goes out to 170 west. Notice it's building along here, getting picked up by the trades, pushing out to the west. The La Nina cool pool was out over in here. It's all gone, getting pushed off, and so a warmer regime has taken hold. And even more interesting, the trend over the past 7 days, see these yellows and oranges, this is all areas of warming. It's not just limited to the immediate coast here, not just limited to the Galapagos, but it's sort of building over a rather large area from 160 west. I mean, we're talking thousands of miles off the South American coast and down into southern, just off of southern Chile. This whole region here is warming, at least over the past week. Now, we're not going to get all excited and say this is some major thing, because we don't know if it is or it isn't, but it is an interesting trend, something to monitor. And you can see the same thing on the higher res overview here, warming off of Peru and Ecuador, even Colombia, and just sort of this whole, it looks like El Nino, but we can't believe it would be, because typically what would fuel El Nino is lots of warm water here, Kelvin waves or westerly anomalies in this region, pushing warm water to the east. It falls to depth. That's a Kelvin wave, and then it works its way over here or ups off the coast. What this appears to be is more a case of just trades weaker than normal, sunlight warming, but still, anything that's getting, there's what the remainder of the La Nina cool pool, and anything that's getting cool water out of here is good for the jet stream, good for storm production in winter months in the North Atlantic, and also good for precipitation into the U.S. West Coast. Now things get even a little bit more convoluted. We're looking at the atmospheric response to all this. Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Everything we have seen so far says the inactive phase of the MJO is in control. If that were the case, then why is the Southern Oscillation Index showing negative numbers? Yeah, we saw this. We saw this minus 40 and 50. These are single-day readings. It was associated with low pressure moving over Tahiti, so one would expect that. But still, we're seeing continued low pressure, or negative numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 days worth here. So that suggests a trend of some sort developing. In fact, when you look at the 30-day running average, okay, so we'll go back here. It's been hovering, 0, a little bit of negative, a little bit more negative, holding like minus 2.322. Yeah, I mean, that's not super negative. That's basically neutral. If it were El Nino, you'd see this down at minus 20, minus 25, something like that. So it's not that, but it's certainly not La Nina either. And then the other interesting part here is the 90-day moving average. If La Nina were in control, well, you'd expect to see this up at plus 20 or something like that. No, that's not the case. And if anything, now it's starting to work its way negative, clearly showing the death of La Nina, but something more, way too early to know. Are we moving towards El Nino? Way too early to know. That would be inadvisable speculation at this time. And then one other index, atmospheric index, what's going on aloft? Rainfall anomalies, the ESPI index. Basically, it's like the Southern Oscillation Index, but it's measuring differences in actual precipitation in the area north of Australia versus a little bit larger than the El Nino region, the Nino 3.4 region, but basically the same sort of thing. Negative suggests less precipitation in this area than normal. Now, last week we were at minus 0.97 or 0.96. It's backed off some at minus 0.89. At the peak of La Nina, we were down at minus 1.96, I believe, or 1.92. So things are slowly pushing back to normal. When you get more precipitation down here, then the index goes positive. So this is still saying La Nina is in control of the atmosphere. Southern Oscillation Index says it's already gone. Clearly in the ocean, La Nina is gone, moving towards something else. This is maybe the last lagging indicator that's still hanging on, saying La Nina has some sort of hold on the atmosphere. We'll go back here real quick. The 30-day Southern Oscillation Index graph. Okay, looking at the trend. So here was back January 2015, January 2016, the El Nino, the depth of El Nino, then La Nina, positive numbers, and now the trend. We had this big run here in November, and remember there was quite a bit of surf associated with that. We had another little run in, where was that? January, February, I think it was, and then a lot of storm activity into the U.S. West Coast. And here we are right now at dead neutral. So that suggests, again, atmospherically, La Nina is dead, but El Nino is certainly not in play. And then finally, the forecast from the CFS version 2 model for the Nino 3.4 region, the main area used for measuring or monitoring El Nino. Of course, the rollout, April 2016, the death of El Nino. Our La Nina, a very weak westward displaced La Nina, peaking out roughly in October, half a degree, not a whole lot more than that. Below normal, that's barely La Nina. And now the forecast, we're into, where are we? We're in somewhere in mid-February, supposedly at 0.3 degrees above normal. Let's go take a look real quick. In the Nino 1.2 region, this one doesn't really count. This is this area right up close there to Colombia, Ecuador, Peru. The temperatures have been positive since, when was that? Late December, mid-December, early December, and are, as expected, looking at all the charts, getting even warmer, plus 1.6 degrees above normal. But again, this is not the area for measuring La Nina, just sort of maybe a forewarning or a harbinger of what's to come. Here's the data from the Nino 3.4 region. Back when we were in La Nina, even in December, down minus 0.8. If you drew a line, an average line through this, about half a degree or 0.4 degrees below normal. But notice, big spike up, dropped off a little bit, working its way back up, just a little bit above normal, plus 0.28 or a third of a degree above normal in the Nino 3.4 region. Portions of La Nina cool waters are still in this region. Warm water encroaching in from the east. One would expect to see these temperatures creeping up over the coming weeks. So, back to the forecast. Here's where we are right now. 0.3 degrees above normal. Yep, that's what we're seeing on the other chart, something like that. Forecast creeping up to half a degree above normal in April. And then 1 degree above normal in July. That's full on El Nino. 1.5 degrees in October. 1.65 degrees in November or so. Now, this is not believable. Other models are suggesting just modest warming, a third of a degree to maybe half a degree. That's not even minimal El Nino. But still, anything above neutral is good. That would be a good sign for the fall and winter, not this year, next year, 2017, 2018, and would suggest a return to a more normal swell pattern, a more normal jet stream pattern. And we've gotten a lot of precipitation for the Sierra. This, if we're in the slightly warm phase or slightly warm temperatures, that would then mean that another year of possibly normal or a little bit above normal precipitation, which is a good thing. And of course, the PDO, we're not going to get into that, but the short is we believe we're moving towards the warm phase of the PDO. All the data that we're seeing, including everything you've seen tonight, suggests pretty much that same thing, that we're not in some long-term cool cycle or La Nina-like cycle. If anything, we're moving towards a long-term, by long-term I mean 20 to 30 years of a pattern that is biased in favor of El Nino, more storm production, more precipitation, etc., etc. So that's all good. But for the immediate right now, we just got to get through the remnants, the last little bits of La Nina. Right now, no significant swell production forecast, maybe a little minor swell for the Hawaiian Islands. Jet stream pretty split. That therefore means probably not a whole lot of precipitation for California for a couple of weeks. But looking at the models, looks like the active phase of the MJO, maybe by the 20th of March or so, should start waking things up. Jet stream consolidating, storm production ramping up, and then again, more storm activity and precipitation for the Sierra. So that's it for this week. Hope you enjoyed it. We'll do it again next week. Same time, same channel. Thanks for watching.